This video we will make a key for the Skill 2 formative on the power, quotient, and product rules. At level 2 we are simply asked to apply the rule, and we see in this case that we are dealing with a rational expression, a rational function I should say, and therefore we will use the quotient rule. As we saw in class, the derivative of the quotient rule can be found by taking the derivative of the expression on top. In this case, that derivative is 4x minus 3, and I'll multiply that by the expression on the bottom, x cubed plus 4x. We also saw, and this was important, we also saw that in order to use the quotient rule, it's important that we are doing this in the correct order, and therefore that we are making sure that we are taking the derivative on the top first, because we're going to end up doing subtraction. So we'll then take the derivative of the bottom, 3x squared plus 4, and we'll multiply that by the expression on top, 2x squared minus 3x plus 1. And then finally, we will divide all of that by the denominator squared. As mentioned previously in class, there is no real benefit to us simplifying this any further. The only thing that can happen is something bad, and us getting it incorrect. At level 3, we're going to involve the tangent line notation, or I shouldn't say notation, vocabulary, and concept. We're going to do that with a symbolically defined function. So not only am I going to attack this with the product rule, I'm also going to use that symbolic notation when taking this derivative. So my product rule states that in order to take the derivative, I will take the derivative of the first expression and multiply it by the second expression. So I have h prime of x times 3x squared minus 2x. I can then add the derivative of the second expression, which is 6x minus 2, and multiply that by the initial expression, h of x. So therein lies my derivative. Now, I want the tangent line. So one of the concepts that I have to get in my head really quickly is, when making a line, I need the following information. I need a y-coordinate, I need a slope, and I need an x-coordinate. My slope is going to come from the derivative. So I'm going to start with m equals f prime of x equals h prime of 2, because we were told we want this at 2, times, when I plug 2 in for x, 3 times 4 minus 4, 3 times 4 is 12, minus 4 is 8, plus 6 times 2, which is 12, minus 2, which is 10, times h of 2. And now I'm going to use that additional information given to me in the problem. I'm told h prime of 2 is negative 1, and h of 2 is 3, so now I get f prime of 2 is equal to negative 1 times 8 plus 10 times 3, or 22, when I do all that arithmetic. So now I have my slope. My slope is 22. I still need an x-coordinate. Well, again, that x-coordinate was given to me. It's 2. So now I'm going to go to here. As I know, I want all my answers in point-slope form, at least to begin. So I have y minus the y-coordinate equals the slope, 22, times x minus the x-coordinate. So what is the y-coordinate? Well, I want this tangent line for f. And f is defined as h of x times 3x squared minus 2x. So at 2, I get f of 2, which equals h of 2 times 3 times 2 squared minus 4, or 8. h of 2 is 3. 3 times 8 is 24. And now I have my final answer. Y minus 24 equals 22 times x minus 2. And again, I'm going to leave it in that form. Lastly, the level 4, which is going to not only take advantage of these rules, but also take advantage of some vocabulary. Again, I see this keyword of tangent, and I'm starting to learn that tangent means derivative, tangent means slope, and it also means that the slopes or derivatives will be the same. So for my line, y prime, my slope is negative 3/4. For my function f of x, I'm going to rewrite that as k times x to the negative first, and then I can use my power rule, giving negative k times x to the negative second. Okay, so I have the slope of the line. It's tangent to that graph. So I know these two slopes should be the same. So I have negative 3/4 equals negative k, x to the negative second, which is the same as putting x squared in the denominator. So over the years, I've seen a lot of kids do this. They then multiply through by x squared, divide through by the negative 1, and get 3x squared over 4 equals k. And think, oh, I'm done. I found k. But we want it to be a number. So tangent also means that the two graphs intersect at exactly 1 point. So I now have an expression for k. I'm now going to solve for k by saying this line has to be equal to this curve at least once. And now I know what k is equal to. It's equal to 3x squared over 4. So now I have the following. Negative 3/4 x plus 3 equals k, 3x squared over 4, divided by x. And if I divide by x, that goes and that goes. So now I have negative 3x over 4 plus 3 equals 3x over 4. Now I can combine the like terms with x. I get 3 equals 6x over 4. And I can solve that. I get that x equals 2. If x equals 2, I can come back up here. And then k equals 3 times 2 squared over 4, which is the final answer of 3. So I'm using tangent both for the derivative, then I'm also using tangent for meaning they intersect at exactly 1 point.